Picture a steaming hot cup of coffee on a crisp, cold morning. The rising tendrils of steam dance above the dark liquid, promising warmth and comfort. But have you ever stopped to wonder why that coffee inexorably cools down, never spontaneously heating itself back up? Why is it that no matter how much we wish, we can never create a perpetual motion machine that generates endless energy? And perhaps, most mysteriously of all, why does the entire universe seem to be marching towards an increasingly cold and desolate future? These questions might seem like simple observations, but they touch upon some of the most profound and fundamental laws that govern everything in our cosmos, from the humble coffee cup sitting on your kitchen table to the most distant ancient stars burning in the depths of space. The laws of thermodynamics are not just abstract scientific principles, they are the hidden rules that dictate the very rhythm and flow of existence. Imagine for a moment the intricate dance of energy happening in that single cup of coffee. Heat transfers from the liquid to the surrounding air, molecules slowly losing their vibrant motion, cooling down until they match the ambient temperature. This simple process encapsulates a universal truth that extends far beyond your morning beverage. It reveals a fundamental principle about how energy moves, transforms, and ultimately seeks equilibrium across the entire universe. As we embark on this fascinating journey, exploring the laws of heat and energy, we'll unravel the cosmic mysteries that explain why things happen the way they do. We'll discover how these laws connect everything from the tiniest subatomic particles to the grandest galactic structures. They explain why time seems to move in one direction, why disorder tends to increase, and why the universe appears to be gradually winding down towards a state of ultimate stillness. So grab your coffee, settle in, and prepare to have your perspective on reality transformed. We're about to dive deep into the fundamental principles that underpin everything we know about energy, heat, and the remarkable mechanism of our universe. If you're excited to unlock the secrets of how the universe truly works, make sure to hit that subscribe button. Just like energy cannot be created or destroyed, but only transformed, your subscription will help transform our channel into an ever-growing community of curious minds, eager to understand the profound mysteries of science. Are you ready to see the world through the lens of thermodynamics? Let's begin. Imagine energy as the most powerful, most versatile currency in the universe. A cosmic legal tender that can never be counterfeited, never created from nothing, and never completely destroyed. This is the essence of the first law of thermodynamics, a fundamental principle that governs every single interaction in the universe. Think of energy as a shape-shifting magician, constantly transforming, but never truly disappearing. When you kick a soccer ball, the potential energy stored in your muscles converts into kinetic energy of motion, but the story doesn't end there. As the ball travels, some of that energy transforms into heat generated by the friction of your muscle movement. Some becomes sound waves from the kick, and some transfers to the ball and the ground upon impact. It's a magnificent, intricate dance of energy transformation. Let's break down some concrete examples to illustrate this principle. A car engine burns fuel, converting chemical energy into mechanical energy that moves the pistons, which then transforms into the kinetic energy of the moving vehicle. The process also generates heat and sound, but the total amount of energy remains constant. A hydroelectric dam converts the potential energy of water stored at height into electrical energy. When water falls, its gravitational potential energy transforms into kinetic energy, which then drives turbines to generate electricity. Some energy is lost as heat, but the total energy of the system remains unchanged. Even in biological systems, energy follows the same rule. When you eat food, the chemical energy stored in molecules is transformed into the kinetic energy of muscle movement, the thermal energy that maintains your body temperature, and the potential energy stored in chemical bonds for future use. This law challenges our intuitive understanding of the world. We often think of energy as something that can be used up, but in reality, it's merely changing forms. It's like a cosmic recycling system where nothing is ever truly lost, only transformed. Consider the energy transformations happening around you right now. The light from your screen, the warmth of your room, the movement of air from a fan. Each is a complex interplay of energy-changing forms. If energy cannot be created or destroyed, where do you think all the energy we use daily ultimately goes? What fascinating transformations occur that we might not immediately notice? The first law of thermodynamics isn't just a dry scientific principle. It's a poetic explanation of the universe's most fundamental operating system. It reveals that everything is connected, that nothing truly disappears, and that the universe is an intricate, never-ending ballet of energy transformation. Imagine a world where things spontaneously become more organized. A messy room suddenly tidies itself. A shattered glass reassembles perfectly. Ice cubes mysteriously form in warm water. But this never happens, and the second law of thermodynamics explains precisely why. Entropy is the universe's fundamental tendency towards disorder, chaos, and randomness. It's the invisible force that explains why your room naturally becomes messy, why heat always flows from hot to cold, and why time seems to move in only one direction. Think of entropy like a cosmic storytelling mechanism. In any closed system, disorder will always increase over time. When you spend an hour cleaning your room, you're temporarily fighting against this universal trend. You're locally reducing entropy by investing energy, but the universe always pushes back. Consider some fascinating examples of entropy in action. Heat distribution. A hot cup of coffee will always cool down in a room, never spontaneously heat up. The energy naturally spreads out, becoming more randomized. Biological systems. Living organisms are incredibly organized structures, but maintaining this organization requires constant energy input. The moment an organism dies, entropy rapidly increases as the complex system breaks down. Information decay. Memories fade, written documents deteriorate, digital files corrupt, all manifestations of entropy increasing. The implications are profound. Entropy explains why. Broken objects don't repair themselves. Complex systems naturally tend towards simplification. Time appears to have a clear direction. The universe is gradually moving towards a state of maximum disorder. If we could zoom out and view the entire universe, we'd see an inexorable march towards greater and greater randomness. Stars will burn out, galaxies will disperse, and eventually everything might reach a state of uniform, undifferentiated energy. What organized system in your life requires the most constant energy to maintain? How much effort do you invest in keeping things from naturally descending into chaos? 0. Absolute represents the ultimate frontier of temperature, a theoretical boundary where molecular motion approaches a complete standstill. It's the coldest possible state in the universe, a realm where quantum mechanics reveals its most fascinating mysteries. Imagine approaching this temperature as an asymptotic journey, like trying to reach the end of a corridor where each step covers half the remaining distance. You can get incredibly close to absolute zero, but never truly achieve it. This mathematical impossibility is a fundamental principle of quantum mechanics and thermodynamics. As temperatures plummet towards absolute zero, extraordinary phenomena emerge. Quantum effects dominate. Atomic particles lose nearly all kinetic energy. Quantum tunneling and other strange quantum behaviors become prominent. Materials exhibit radically different properties. Superconductivity emerges. Some materials lose all electrical resistance. Electric current can flow without energy loss. Magnetic fields can be perfectly expelled. Quantum condensates form. Atoms begin to behave as a single, unified quantum entity. Bose-Einstein condensates represent matter in an almost mystical state of collective behavior. Individual particle identities blur into a collective quantum wave. The third law isn't just about cold, it's about the fundamental limits of physical behavior. It reveals that as we approach the coldest possible state, the universe reveals its most counterintuitive, mind-bending characteristics. At absolute zero, we touch the boundary where classical physics breaks down and quantum weirdness takes over. It's a realm where our everyday understanding of motion, energy, and existence dissolves into probability and wave functions. Curiously named after the other three laws, the zeroth law of thermodynamics is the foundational principle that explains thermal interactions at the most fundamental level. It introduces the concept of thermal equilibrium, the state where different systems, when brought into contact, eventually reach the same temperature. Think of thermal equilibrium as nature's ultimate balancing mechanism. When your hot coffee meets the cool air of the room, heat energy spontaneously transfers from the warmer object, coffee, to the cooler one, surrounding air, until both reach the same temperature. This isn't just about coffee. It's a universal principle governing every thermal interaction in the universe. Key implications of thermal equilibrium. Temperature measurement provides a consistent method for temperature comparison, allows creation of temperature scales and thermometers, enables precise scientific and engineering measurements. Energy transfer mechanisms explains heat transfer through conduction, convection, and radiation, demonstrates how energy naturally seeks balance, reveals why heat always moves from hot to cold. Biological and environmental significance regulates body temperature in living organisms, drives climate and weather patterns, influences ecological systems and energy exchanges. The zeroth law isn't just a technical principle, it's a fundamental description of how energy naturally seeks harmony. From the smallest atomic interactions to planetary climate systems, thermal equilibrium governs how energy moves and balances. In thermal equilibrium, we see a profound metaphor for balance, a reminder that in nature, differences naturally seek resolution, and energy always finds its most stable state. These thermodynamic laws transcend mere scientific principles. They reveal the ultimate narrative of our universe's fate. As entropy continuously increases, we are witnessing a grand, inevitable progression towards what scientists dramatically term the heat death of the universe. Imagine the universe as an immense, complex system gradually running down like a cosmic clock slowly losing its energy. The second law of thermodynamics suggests an inexorable march towards maximum disorder, where all usable energy becomes evenly distributed, rendering further meaningful interactions impossible. Entropy's relentless increase. Energy becomes uniformly spread across space. Structural complexity progressively breaks down. Potential for work and transformation diminishes. Stellar life cycle. Stars eventually exhaust their nuclear fuel. Galaxies disperse. Black holes slowly evaporate through Hawking radiation. Ultimate cosmic state. Temperature approaches absolute zero. No temperature differences to drive energy transfers. Complete thermodynamic equilibrium. This isn't just a scientific prediction, it's a profound philosophical revelation. The universe is storytelling its own gradual dissolution, where complexity gives way to ultimate simplicity. The most remarkable insight? Even as individual systems can temporarily create order, the universal trend towards disorder remains inevitable. We are witnessing a cosmic performance where energy's final act is complete, uniform distribution. The thermodynamic laws reveal a profound truth about our existence. Life is a precious temporary rebellion against the universe's natural tendency towards disorder. While the ultimate fate of the universe might seem bleak, a gradual descent into uniformity and stillness, These laws simultaneously illuminate the extraordinary nature of our brief, organized moments of existence. We are not passive observers, but active participants in a cosmic drama of energy transformation. Temporary order as miracle. Life represents a remarkable local reduction of entropy. We create complex structures by continuously investing energy. Our ability to organize and create is a defiant act against universal randomness. Value of conscious effort. Maintaining order requires constant energy and intention. Each moment of creation, learning, and organization is a triumph. Our conscious choices can temporarily resist the universal trend towards disorder. Interconnectedness of existence. We are part of an energy exchange system. Our actions have cascading consequences. Every effort to create, maintain, or improve represents a meaningful intervention in the cosmic process. We are not victims of entropy, but its most fascinating manifestation. Our consciousness, our ability to understand these laws, and our capacity to create temporary islands of order are themselves miraculous expressions of the universe's complexity. The universe may be moving towards stillness, but in this moment, right now, we have the extraordinary opportunity to create, to love, to understand, and to marvel at our brief, brilliant existence. Thermodynamic laws are the fundamental rules of a cosmic game we all play, whether we understand them or not. They reveal a profound truth. While we cannot ultimately defeat the universe's natural tendency towards disorder, we can create temporary islands of order and beauty. We are momentarily pushing back against the universal trend towards chaos. We are creating local pockets of complex, beautiful organization in a universe that constantly moves towards simplification. If you've been amazed by these fundamental laws of the universe, don't forget to subscribe on the channel, like this video, share with friends who love cosmic mysteries.